discovered that mass is neither created nor destroyed in chemical reactions. In other words, he discovered the law of conservation of mass, one of the fundamental laws of the universe. Conservation of mass. In other words, whatever you have that's coming in a chemical reaction, you will get out. Okay, so in this case, on the left-hand side of this chemical equation, we've got hydrogen and oxygen. On the right-hand side, you have to have hydrogen and oxygen as well. It's also nice to draw a diagram. So H2 looks like this. Think of hydrogen, two hydrogen atoms connected. On the left-hand side, similarly, two oxygen atoms connected. That's O2. Think of it as like a seesaw. Right-hand side, two H's, only one O. Okay, the seesaw is not balanced. It appears that the left-hand side is heavier. So how do we go about fixing this? Well, we do what's called balancing this chemical equation. So let me show you how to balance this. Now, the rules of the game are as follows. You can only add things, coefficients. These are called coefficients. If you think back to maths, these are just numbers, coefficients, okay, in front of these expressions here, in front of this formulae. And you cannot change here, the numbers here, the subscripts. You can't change them at all, because that's like creating and destroying matter, which we can't do. So the first step is to take an inventory, okay? In other words, write down what elements there are on the left-hand side and right-hand side. So on the left, and write this down in order. There's hydrogen. I'm going to write H for hydrogen, O for oxygen. Similarly, on the right-hand side, there must be H and O, okay, in the same order. Let's now count. So that's step one. Step two, let's now count how many hydrogens there are. Two. Oxygens, there are two. On the right, there are two, and there's one oxygen on the right. Okay, that's step two. Step three, we can only multiply, okay, these numbers here. What do I mean by that? Well, hydrogens are fine, tick, tick. Okay, there's two on each side. Oxygen, there isn't. How do we turn this 1 into a 2? We can only multiply. These are the rules of the game. To turn 1 into 2, I'll multiply by 2. And I'll put a 2 out the front. Now, this is a compound. Be very careful. H2O, that's one compound. I have to put parentheses. So not a problem with the oxygens. However, the hydrogen now becomes 4 because you've got 2 times a hydrogen molecule, which is 4. So this is now 4. Cross this out and put 4. So let's now turn this into a 4 over here. The way we do that is we multiply by 2. And we put a 2 out the front. And there we go. That's how we balance an equation. It takes a lot of practice. Okay, it's not something you can learn from the get-go unless you're highly competent. Let's do another example. Let's do this. Fe2O3 plus C makes Fe plus CO2. Okay, now let's see if this is balanced or not. So let's take an inventory. First step, Fe, I can see O and I can see C. On the right-hand side, similarly. Fe, well, there's 2 iron atoms. Oxygen, there's 3. Carbon, there's 1. On the right, iron, there's 1. Oxygen, there's 2. Carbon, there's 1. Now, clearly we can see here it's not balanced. Let's balance it. Coefficients. Okay, it's just a good habit to get into, writing down the coefficients out the front. Get you into the thinking mode. Let's start off with iron. Let's turn this iron on the right into 2. Multiply by 2. So we'll put a 2 here. Not a problem. Irons are good. Oxygen now. Now, whenever you get this, something like this, you got 3 here and 2 here. Use the least common multiple between the two numbers. Okay. In other words, what divides into both numbers? Well, it's 6, right? So to get 6 on the right-hand side, we multiply this by 3, and we get 6. Okay, so to have 6 oxygens on the right, we put a 3 here, right? Because 3 times 2 is 6. So far, so good. And that now, this also changes the amount of carbon, right? So there's now 3 carbons, okay, because 3C. So I should mention 3C is the same thing as 3 times C times 3, right? There's 3 carbons here. So the left-hand side, turn this into a 3, times it by 3, put a 3 at the front. And the oxygen here, times it by 2 to get 6. So we'll put a 2 at the front, and that's now balanced. Let's do another. Let's do N2 plus H2 makes NH3. Okay, let's make ammonia. This is called the Haber process, Haber. Okay. Let's check if it's balanced or not. Okay, so NH. Take an inventory. There's 2 nitrogens on the left, 2 hydrogens on the left. There's 1 nitrogen on the right and 3 hydrogens on the right. Not balanced. So let's balance it. I'm going to put in coefficients. Okay, let's start with the nitrogens. On the right hand side, times it by 2 to get 2. So we'll put a 2 at the front. Make sure to put parentheses, brackets. Now we have 6 hydrogens, 2 times 3. Right, so there's now 6. How do we turn the left hand side into a 6? We multiply this by 3. So we'll put a 3 at the front here. And so now it's balanced. Okay, and that's the idea of balancing chemical equations. It's a step-by-step process.